Hi everyone, very good evening. Myself Harun Raseed, and I'm a data engineer specialist, and I'm a Microsoft MVP in data platform. So today I'm going to take a session on this real-time predictive maintenance for the manufacturing equipment using the Azure services along with Databricks and other tools that is needed for the streaming data processing. Okay. So let me go and start with the presentation first. Then I will go ahead and give you the actual demo. So first of all, we need to know what is data, right? Because before going to do the real-time prediction, all those things, we need to know what is data and what kind of data that we are going to predict, and what kind of algorithm that we are going to use. All those things are there. Okay. So everything is data. Anything is data. Okay. Like in our day-to-day life, whatever we are using, whatever we are consuming, everything is a data. Okay. We generate lot of data and we consume lot of data. So that kind of data, how we are going to convert that into a valuable insight for business requirement only we are going to see today. That too we are going to see how we are going to do the stream analysis. Okay. So data is the new oil. That means every company is a data company now. That means each and every data is very important, and it matters how we are well utilizing the data. Okay. So obviously nowadays there is no concept called small data set, right? Everything is a big data. Okay, if you take any small organization, any small project, the data is going to be very big because for a fraction of second we are generating millions of records, right? So everything is a big data. When we call some data as a big data is when the volume is huge, when the variety of data is different, okay, and the velocity is also high and the veracity is also there. Okay, when this four v's comes into picture, then we claim that as a big data. Obviously nowadays every data is a big data. Okay, so how well we are going to handle this big data, that plays a major role in the efficiency part. Okay. So, and this core concept called a batch versus stream. Okay, so here you can see pictorial representation of what is a batch process and what is a stream process. Okay, so in batch processing, what we are doing is we are just going to record the events, and the recorded events we are going to process in a periodic way. Okay, so the periodic data we are going to process, do the transformation, and then we are going to submit to the sync in the sense the destination. From there we will be generating the reports. So that is batch processing. So in the other hand, we have something called streaming processing. So in streaming processing, the processing of data is going to be real time. So when I'm going to generate a record, I'm immediately going to process it. Okay, so that is how the real world behaves nowadays, right? So we don't have time to wait for my transaction to get, say, whether it is succeeded or failed. Okay, I can't wait for like 30 minutes or 20 minutes. I need to know immediately whether my transaction is succeeded or not. That's a kind of a streaming data. You pay the bill and you need to know whether it's succeeded or not. Okay, so let's take a classic example. The batch processing, you can relate it with your NEFT and transaction, and stream processing you can relate it with the IMPS transaction, where NEFT takes 30 minutes or 1 hour. It totally depends on your bank, right? For example, bank called ABC, they run their NEFT process every 2 hours once. That means 8 a.m. you are sending or 8:30 a.m. you are sending the amount. The next batch starts at 10 a.m. only. So you need to wait till 10 a.m. To make that transaction complete. But IMPS, that is not like that. Immediately, once you send the amount, immediately it will go to the destination, right? So that is how you can differentiate between the batch processing and stream processing. Okay, I hope you all got some hold on batch and stream processing now. Okay, so we are going to see both, like how batch processing is going to help and how stream processing is going to help. Okay. Okay, so now let's deep dive into this concept called predictive maintenance, the two real-time predictive maintenance. So before going into predictive maintenance, we need to know what are all the other maintenance techniques available. Okay, let's take manufacturing industry or any other industry, right? Manufacturing industry or aircraft, okay, engines, all those things are there, right? There they need to maintain their equipment. Okay, so maintenance in the sense, for example, if a machine, let's take a aircraft. If the aircraft is flying, they need to change the equipments frequently. Okay, they need to know whether this equipment will fail in near future or like that. They need to check and they need to do the precautionary steps. Okay, if they're not going to do that, what will happen? Okay, let's take they are not doing any precautionary steps. If something fails during the runtime, it's going to cause a huge loss. Okay, so let's first see what are all the maintenance techniques are there, and why predictive maintenance is important among all the other methods. Okay, so this is the reactive maintenance. Okay, this is where we are going to make the equipment changes only after it fails. Okay, but it can give you the maximum life of that equipment. For example, if an engine can run for 1,000 hours, 1,000 hours, 1,000 run hours it will run, then it will fail. Okay, so the engine will attain its maximum runtime and then it will fail. But here the consequences is, during the runtime, if it fails, what will happen? During an aircraft runtime, if the engine fails, what will happen? It is going to cause a huge loss. Okay, so this maintenance, this reactive maintenance, is having some problem. Okay, so it will also cause some unplanned maintenance, right? But suddenly, if it fails, you need to do some maintenance activity to overcome from it. So this is a problem. So they have another maintenance method called as preventive maintenance. So what is preventive maintenance? For example, if you know that engine can run for 1,000 hours, what you will do is, when the engine completes its 950 hours, you will go, you will change the engine. Okay, but here what's the problem is, you are reducing the runtime of that particular engine. Okay, even though it is having 50 more hours the runtime, you are going and changing the engine in the 950th hour itself. Okay, but here also the planned maintenance will be there, that is fine, but failures will be comparatively less, because before failure itself you are going and changing the engine, right? So you can see the machine 2 and machine 5, right? There are more time available for that machine to run, but before itself that maintenance happened. Okay, so this is called preventive maintenance. But here also some efficiency is dropping, because we are stopping the engine at 950th hour itself. So that is also a problem. Okay, so what else we have? Then we can go with the predictive maintenance. That is what we are going to see, how programmatically we can do the predictive maintenance. But before that, I will show you what is predictive maintenance. So this is predictive maintenance. So here what is going to happen is, based on each and every individual machines, we are going to collect the information. For example, let's take an engine. So we will be capturing the temperature, we will be capturing the RPM of that engine, everything we will be capturing. Okay, so based on the data that we capture, we will be running some algorithm, and based on the data, we will decide, okay, this machine, this is the time, or after 2 days you can do a maintenance for this machine. So like that we can do some predictive maintenance. We can actually predict the efficiency of the machine, or we can actually predict the lifetime of the machine. Based on that predicted date, we can go and do the maintenance. So in this, what is happening is, we can achieve like 98 percentage of the runtime of the machine. No failures is also there. With the planned minimal planned maintenance, we can achieve this. So here we are maximizing the lifetime of the machine, as well as the uptime is also increased here. Okay, so this is one of the core method that every other automation industry or aircraft industries are following, called as predictive maintenance. Basically, data driven maintenance. Okay, based on the data, they are going to act upon it. So now I'm going to show you how we can act upon the data. Like as I said, let's take the aircraft example itself, or any manufacturing industry, whatever it is you are working on. Okay, so there will be some equipments. So from each and every equipments, I'm going to collect some data, like the temperature, humidity, RPM of the machine, like that. Multiple informations I'm going to collect. Okay, so with that information, what I'm going to do is, I'm going to run a AAML model. So that model will tell me, okay, this is the time, go and change the machine. There is some anomaly in this machine, go and change this machine, go and change this equipment, like that it will say. Okay, so that I'm going to show you how we can do it using the Azure IoT, Azure Databricks, and other some visualization tools also. Okay, so before deep diving into each and every components, I'm going to show you the architecture of what we are going to do. Here you can see the input is going to come from IoT, because all other machines, whatever the equipments that we have, what we will do is, we will connect it to IoT devices. From the IoT hub, we will be capturing the data. Okay, so that particular data, what we will do is, we will pass it to our stream analytics job. Okay, so that stream analytics job, what it will do, it will dump the data to the destination. Okay, so that is what we are going to do now. So I'm going to read the data through IoT hub, and I'm going to dump the data to a storage account. From that storage account, I'm going to do the data transformation, and I'm going to visualize that data as well. So this is what I'm going to do now as a demo. Okay, so let me go and share my screen of the demo. Okay, I hope my screen is visible to you all, the Azure portal screen. Okay, so this is Azure portal. So in this Azure portal only, we are going to create our Azure services and create our data bricks and do the transformation, all those things. Okay, so if you're new to Azure portal, you can get the free version of Azure portal, like 100 USD credit free, and access Azure portal, create some basic resources and get familiar with this. Okay, so I'm not going to show you how to create resource, all those things, because those are fundamentals. So if you're new to Azure, just get the free credits and explore on it. Okay, so as of now, I'm going to have a IoT hub. Let me show you the IoT that I already created. So this is the IoT hub that I already created. Okay, so as of now, I don't have any equipments to generate the data, right? Like I don't have any engine or motors to generate the data. For that, what I did is I have written a Python code which will generate some random data. Okay, so this is my Python code. I have configured this Python code with my Azure IoT hub. Okay, this is the connection string from the IoT that I have given. So what will happen is, here I'm using a generate data function to generate some random data. Okay, with some equipment name called engine, turbine, generator, like that. So it is going to generate some random data on temperature, pressure, vibration, all those things. Okay, so what I'm going to do is I'm going to generate data. How the data will be is, the data is going to be in a JSON format like this. You can see, right, the equipment name, temperature, pressure, all those things. These are all some random data I'm going to generate. Okay, so this is how the real-time data also will be coming, but in real time, the data will be coming from actual instruments or the actual equipments. But now I am generating the data through a Python code. Okay, so let the data get generated in the backend. Uh, I'm going to show you the spikes here. You can see some spikes here when I start hitting that query, or that when I start executing that Python code, I can see spikes here. Let me refresh this. So I can see spikes here. You can see, right? So on my particular timing, the data started generating. Okay, so this is how we will be getting the data into my Azure portal using Azure IoT Hub. Okay, so next, once I got the data into Azure IoT Hub, I need to have something called Azure Stream Analytics job. Okay, so for that we have other service called Stream Analytics. You can see something called Stream Analytics job, right? I have already created one Stream Analytics job called Season of AI Stream. Okay, let me open it and show it to you. So here, if you see the job topology, input will be there. Here I can go and configure my input. So what input I need to give? I need to give my IoT hub as a input. Okay, so you can see, right, IoT hub I have given as a input. So this is my input. So once I capture the data from the equipments, where I need to dump it, I need to dump it in the storage account. That is where I'm going to store all my data. So if I go to output, I can see, you can see, right, I have added one output here. That output is nothing but my storage account. Okay, so in this storage account, I'm going to dump all my data in a container called a stream container. Okay, so if I go to my storage account, stream input. Okay, in this stream input, I'm dumping all my data. You can see the latest data 417 it is showing, right? If I refresh it, my data started populating. Okay, I know why, because my stream job is not running. Let me go and start my stream job. Okay, so if I start the stream job, then only the flow will come from input to output. Okay, as of now, you saw, right, my storage account is having a data as of 417, that is 1 hour back. Okay, but now I started populating some data. See, it is 417, and now my data is populating. Why it is not coming here? Because my stream job is not running. So I'm going to start the stream job now. I have started my streaming job. Okay, it will take couple of seconds for the first time to start. Once it started, right, what it will happen is it will start picking the data from the input and put it into the output. My input is IoT hub and my output is storage account. Okay, we will allow a couple of seconds so that the job will start and it will push the data to the storage account. My stream analytics job is still starting. Yeah, it started and it is running now. Okay, so once it started running, what will happen is it will start picking all the data from my source, that is from my equipments, and it will push it to the destination, that is its job. Okay, so you can see the input is from IoT. From IoT it will pick all the data and it will put it into the output. Okay, so if I go and refresh it now, you can see data at 5:18 my data started generating. Okay, so like this I can have my JSON files in my container called stream input container. But now I have a data as a JSON file. I cannot derive any valuable insight from this JSON file. Business cannot get any valuable insight from it. So how to get a valuable insight from it? You need to process this JSON data, right? Equipment wise, how many anomalies are happening, or equipment wise, when is the maximum temperature is reaching? All those things we need to calculate, and we need to do some predictive analysis. Okay, this is just a data. Okay, all this time I have shown you how to get the actual data from the equipment into our system. Now I have my data. Now I need to cleanse this data, do the transformation, apply the AML algorithm, all those things. Okay, so for that, what I'm going to do is I'm going to use Azure service called Azure Databricks. Okay, so Azure Databricks is nothing but a service where it works on the Spark principle. The architecture is on Spark, where you can go and write your PySpark code or SQL code or Scala, whatever language you're comfortable with. You can go and write your code. So it works on the principle of Spark, I said, right? So it supports a big data analysis. Okay, so let me show you how to go to Azure Databricks. So if you search for Databricks, you can see Azure Databricks here. I have created one Azure Databricks for this particular process. That is this one, ADB workspace for season of AI. Okay, so if I launch this, so I got logged into my Databricks workspace. Okay, so inside this workspace I can go and write my notebooks. Okay, so I can go and write my notebooks and access the data from the storage account. Ultimate aim is to access this JSON data and do some processing. Okay, first I will show you how in a batch we can access it. As of now, this is a stream. Okay, this entire data that I am getting from the source to the destination as a storage account is a stream. Okay, so further we can process it in a batch or streaming process also. Okay, so let me go to the batch process notebook that I have created. So batch process, what I'm going to do is I'm going to read whatever is available currently in the JSON file. Okay, so this is the path that I have mounted. There is a concept called mounting, because this storage account needs to provide access to this Databricks to get the files, read the files, write the files, right? So for that we need to do something called mounting. Okay, so that I already did using this mounting notebook. I have provided all the configuration information of the storage account and I have mounted it, and I'm going to call it as mount data lake path. Okay, and the container name is stream input. basically where my JSON files are getting landed. You can see here, right? Stream input is the container where my JSON files are there. That only I'm mounting here. Container name and the storage account name. This is my shared access token from the storage account, and I am mounting in my Databricks as /mnt slash data lake path. Okay. So now my data will be available in this particular path. Okay, that you need to know. Let me. Okay, I just started the cluster so that I can show you by executing the code. Okay, before that, let me explain you about this notebook or the transformation code that I have here. So these are all the functions that needed for this. So I have imported all those things. If you see here, I'm going to read all the JSON file that I have. So I have said start.json. I can have multiple JSON files here, right? Like 4 a.m. I received, 4 p.m. I received one file which is going to have some 1,000 records. Now I have generated some 1,000 records at 5:20. Again 6 o'clock, like that. Continuously, if I'm going to run, one file will get appended. If I'm going to run it in some breaks, means it will create multiple files. So I don't want to miss any file. So I'm going to say slash start.json. Okay, and I'm going to read the data into a data frame. Then after reading the data frame, I'm going to convert the temperature to Fahrenheit. I am applying some formula. Then I'm going to convert the timestamp to a readable timestamp. Okay, that also I'm doing. But my main thing here is to do the anomaly prediction, because now my data is this only. Okay, here with this data I cannot say whether this turbine is having some problem or not, because here temperature is this, pressure is this, vibration, RPM, everything is there. With this data I cannot say whether this turbine will uh, create some issues in near future or not. To know that, what I need to do is I need to do some prediction. How I can do a prediction? If I have some historical data, like if I have some thousands of historical data about turbines which got fault in this particular temperature and this particular vibration, all those things, then with the available historical data I can compare this data, and I can say, okay, this turbine will be a fault turbine in next 2 days, or there is some anomaly in this turbine, change this turbine, like that I can say, right? So what we have is we have a Hugging Face model. Okay, this large MNLI model we have. Okay, so we are going to leverage that model to do this predictive classification. This is an open source model that we have. Okay, anyone can use from Hugging Face. I have just imported that transformer. Okay, and I'm going to use that here. That's it. I have my source data and I'm going to apply this AML model on my data. Okay, after applying, what I'm going to do is I'm going to say whether, based on the output, whether it is a normal or there is an anomaly. If it is normal, I'm well and good. If there is any anomaly, then I need to go and change the equipment. Okay, because the temperature is high and the pressure is high. Based on the historical data, it is going to say there is an anomaly in it. Okay, that is what we are going to do. For that, I have this anomaly detector class I have created. So this particular anomaly detector I'm going to apply on my data. You can see here, anomaly detector I am going to apply as a lambda function, and I am passing all my information, the data that I achieved from IoT, temperature, pressure, everything. So it is going to calculate, okay, if at this temperature, at this pressure, there is an anomaly. This is called as anomaly. At this temperature and this pressure, low pressure and medium temperature, there is no anomaly. So that kind of calculation will be happening with the help of this anomaly detector. Okay, so that is what I'm going to do. Then the final data frame, transformed data frame, I'm going to write it as a result df. Okay, so you can see this is the final data frame. Timestamps will be there, and IoT information will be there, and this is my equipment name, and this is the humidity level, noise level, everything. So by calculating all this information, it is going to say the anomaly prediction is whether it's an anomaly or it's a normal. Okay, as of now I have all faulty data in the sense all my equipments are overused. So only you can see, right, the temperatures are very high. Okay, the noise levels are very high. So only my all my equipments are anomaly. If at all any good data comes in, good data in the sense, if any equipments which is running fine comes in, this model will detect it as a normal. Okay, as of now I have 82 records, so all the 82 equipments are having some anomaly now. Okay, so with this I can come to a conclusion there is some issue going on in my plant, okay, or in my aircraft. So with this table also, some people needs to go and check each and every record, right? So how we can present this data to the end users? So that what I'm going to do is I'm going to write this data into a table. Okay, so writing this data frame into a delta table called anomaly detection. Okay, I'm just dropping this IoT hub column here because this IoT hub column is not going to give any information to me, valuable information to me. Okay, so I just dropped this column from the data frame and writing the data into the delta table. So now I will be having a table called anomaly detection. If I go and query the table, I can able to see all the data that I'm having in this data frame. Let me go and show you from the SQL editor in Databricks. So this is my table anomaly detection. I'm just going to execute this code. So here also I'm going to get in the tabular format only. But what we can do is this delta table data, we can push it to a Power BI or Tableau or whatever visualization tool you know. There you can push this delta table and visualize it. Or else in Databricks itself, you have a visualization. Okay. So how to do that? Just click here, go to visualization, and based on the data you choose what kind of visualization you want. Let me go with a pie chart now. Okay, so or let me go with a bar chart. I have equipments, right? So I'm going to say my equipment name and the count of anomalies in each and every equipments. How many equipments I sorry how many anomalies happened, like that. In y-axis let me give anomalies and the count. Okay, so now this bar chart is showing me compressor is having 16 anomalies, cooling unit is having 26 anomalies, engine is having 13 anomalies, like that. Equipment wise it is giving me the anomalies count. That means these many issues I am having on each and every equipments. Okay, so with this we can come to a conclusion, okay, there is some issue. Like this multiple pie charts, bar charts, like this multiple visualization you can create. Okay, so you can see 26 percentage of the cooling unit, 10 percentage of generator, all those anomalies are there here. Okay, so this is how we can take some data driven decision. Okay, with instead of relying on the machine to get failure, or instead of waiting for some maintenance time to go and do the maintenance, with the help of data driven we can go and do some actual decision on changing the equipments. Okay, so this is the end-to-end process of acquiring the data from the source and pushing it to the storage account, then reading from the storage account and doing the transformation, applying a AI ML logic over the data, and finally visualizing the data, saving and visualizing the data. Okay, so I hope you all got some hands-on experience. You will get hands-on experience once if you go and try on this. So for that, what I would suggest is there is a community edition of Databricks available, and in Azure also there is like a 1 month free trial is available. So try to utilize all those free resources. Once you're comfortable with that, then you can go for pay-as-you-go subscriptions. But there are these two things available. Okay, please try and go with all those free resources. Okay, I think I'm good with this. Let me share you the overall architecture that what we did. Okay, so what we did is we did a streaming source. From the stream, we read the data, and using the Azure Stream Analytics, we process the data. Means processing in the sense we acquired the data from the source and we push the data into destination. From that storage account, we took the data and we processed it. Okay, and we are showing it as a real-time dashboards. Okay, so this is how we will be doing the entire end-to-end part. One more quick thing, I have shown this batch process, right? This batch process at the current time when I read this JSON path, how many records are there, it will give me. But what if I want to run continuously in the sense whenever a new equipment failure comes, or whenever a new equipment information comes in my source. Okay, as of now this is my source, right? Whenever a new record started populating here, let's take, whenever it start populating here, immediately I need to process it. But in this batch process, I cannot do that, right? Because in batch process, every time I'm going and reading this individually. So for this, we have something called stream processing in Spark, in Databricks, whatever you can say. Okay, so this is called a Spark structured streaming. You can see the difference here. In batch processing, I'm going to read it as spark.read. Okay, so in stream processing, what I'm going to do is I'm going to read it as spark.read stream. Okay, that is the difference. So here I'm going to read it as a streaming data. So the same streaming data that is present in the storage account, I'm going to read it in the stream format, and I'm going to do the transformations here. And then writing also, I'm going to do it as a write stream instead of simply saying a df.write.delta. You can see in batch process, I will show you. So this is a batch process. Here what I'm saying, data frame dot write dot delta format, and I'm just saying append mode, right? So this is just a batch write. If it is a stream write, you can see data frame dot write stream dot format delta append mode. So if it is a stream, definitely I need to have a checkpoint, because if any issues happen during the execution, it needs to catch up from the point where it failed. Okay, and processing time I'm giving 10 seconds, and I'm going to save it as a managed table called anomaly detection table. Okay, so this is how we will be processing the data in a streaming manner. Okay, in batch also you can do, in streaming also you can do. But if you're doing in a stream process, then your cluster needs to be up and running. Cluster is nothing but the computing resource. Okay, so you need to pay more. Obviously you're going to pay more if you're going to run the cluster all the time. Okay, so that is the difference between this batch and streaming process. I hope now you got in-depth idea about how to process the data in a batch, how to process the data in a stream also. Okay, so with that, we have completed this entire end-to-end process. Okay, if you have any queries, or if you want to reach out to me to know more about this stream process, batch process, or the source code of this, or anything related to data, if you want to have a quick chat with me in through my LinkedIn. This is my LinkedIn name, profile name, Harun Rashid Basheer, and this is the QR code which will navigate to my LinkedIn ID. And I write many blogs in LinkedIn, as well as my Medium page and C Sharp Corner page. You can go through my blogs over there as well. Yeah, that's it from my side. Thank you,
Perfect.
everyone.
Thank you so much, Harun. And let's do this more often. Thank you so much. Thank you for doing this on a weekend.
Yeah, sure, sure, Rohit. Definitely,
Bye.
definitely, we will connect often. Yeah, thank you.
Okay.
Happy weekend. Bye.